Do you think the James Webb Space Telescope was the peak of technological innovation, engineers, and space industries? That's nothing but a tip. The fun just began. As 2021 draws to a close, astronomers' eyes were fixed firmly on the James Webb Space Telescope, JWST, as it lifted off the Ariane 5 launch vehicle. The JWST was one of the most eagerly anticipated scientific instruments in history, promising to provide us with a plethora of breathtaking surprises. Deeper insights on the early cosmos and the atmospheres of alien planets orbiting other stars. And so far, Webb has indeed kept to its promises. But the JWST, which took over 20,000 engineers and hundreds of scientists to build, is far from being the end of the story. According to John Mather, a Nobel-winning astronomer and a leading force behind the James Webb Space Telescope, many more groundbreaking observatories will be launched during the next decade or so. Here are three of the most astounding ongoing projects: the European project Euclid and NASA's Nancy Grace Roman Space Telescope, both of which will search out answers to the long-standing puzzle of dark matter and dark energy. That sounds exciting. As well as the Vera Rubin Observatory, a massive project under construction in Chile's high deserts that would scan the entire sky for minor changes known as transients. What does that mean? A transient is an observed phenomenon in the sky that involves a change, such as the appearance of an astronomical body or a change in its appearance. They are detected by observing an area multiple times and noting the differences. Typically, they are extreme, short-lived events that could occur in a fraction of a second, weeks, or even years, but are often connected with the total or partial destruction of an astronomical object. Astronomers believe the Vera Rubin Observatory will detect millions of such each night, so numerous that sorting through them all will be difficult. Perhaps we could recommend ChatGPT to help them in that aspect of sorting through data. What do you think, viewers? Now to the big question: which is coming first? When will it be launched? And of course, details about its construction. John Mather, who spent decades making the James Webb Space Telescope a reality, shared his perspective what the engineers and scientists may tackle next. On Thursday, January 12th, the final day of the 241st meeting of the American Astronomical Society held in Seattle and virtually. Going forward, the next hugely ambitious project could see the Nancy Grace Roman Space Telescope, he said. JWST is a demonstration that we can do hard things, and we're going to continue to do hard things. The next big astronomical goals will require similar dedication and creativity, he added. Roman Telescope, expected launch date in less than 5 years. Like Webb, the Roman Space Telescope was named after the first female executive at NASA and will primarily observe infrared radiation. But while the JWST concentrates on details and origins, Roman will focus more on the big picture. The panoramic range of view of the telescope is 100 times that of the JWST. Within its first 5 years, the Roman telescope will capture more than 50 times as much sky as the Hubble Space Telescope did in its first 30 years. It would cover a significant portion of deep space and be able to make a wide infrared mapping of the sky. Scientists are counting so much on this telescope to help unravel mysteries like the true identity of dark matter and dark energy. Astronomers can see the influence of these substances on the universe, but have not been able to explain what they are. A few outstanding features. The telescope has a primary mirror that is 2.5 meters in diameter, or 7.9 feet, similar in size to the Hubble Space Telescope's primary mirror. Roman will be equipped with two incredible instruments, the Wide Field Instrument and the Coronagraph Instrument. Since the Wide Field Instrument will have a field of view that is 100 times greater than that of the Hubble telescope, it will capture more in less time. Hubble's camera has a field of view of 130 by 130 arcsecs, while Roman's camera has a field of view of 2,700 by 1,380 arcsecs. The Roman is like a fleet of 100 Hubbles operating at once. Here's a picture of the Andromeda Galaxy. It took Hubble 650 hours to image the blue outlined area. Roman will be able to image the entire galaxy in just 6 hours. Over the duration of the mission, the Wide Field Instrument will measure light from 1 billion galaxies while conducting a microlensing scan of the inner Milky Way in search of exoplanets, while the Coronagraph Instrument will observe those exoplanets deeper than the Hubble telescope by performing high-contrast imaging and spectroscopy of each exoplanet. The Roman Space Telescope's primary mission would span 5 years, with the possibility of extending it for another 5 years. The telescope is currently in development and scheduled to launch in May 2027. These are not mere speculations. There is already a launch approval. In 2010, the US National Research Council Decadal Survey Committee proposed Roman as the top priority for the next decade of astronomical projects. And on February 17, 2016, it was approved for development and launch. So, if there ever would be a delay, it would be more of technical issues. The development cost is estimated to be between $3.2 and $3.934 billion. The Nancy Grace Roman Space Telescope, also known as the Roman Telescope, formerly called the Wide Field Infrared Survey Telescope, or JWST, is named after Dr. Nancy Grace Roman, an iconic woman who paved the way for women in space travel. She was NASA's first chief of astronomy and the first woman to hold an executive position in the industry. Nancy Grace Roman was a proud AAUW member and a true American hero, also known as the mother of the Hubble. She was instrumental in making the Hubble Space Telescope a reality. Back then, teamwork was critical to the creation of the Hubble Space Telescope. The idea of having a large telescope above the atmosphere was not new to the astronomical community when Dr. Roman came to NASA, but she was the one to turn the concept into a reality by bringing together world-class astronomers from across the country to collaborate with NASA engineers. At the time she joined NASA in 1959, the agency was just 6 months old. Her work was instrumental in establishing NASA's program of space-based astronomical observatories. She took an early retirement in 1979 but continued to consult, teach, and advocate for women in the sciences until her death in December 2018 at the age of 93. In addition to her trailblazing accomplishments, Dr. Roman left a legacy for future generations. She died in 2018, and in 2019, AAUW received a generous donation from Nancy's estate to ensure more girls and women can pursue scientific careers, particularly in engineering and the physical sciences. Looking a bit further down the road, the next massively ambitious project is the Habitable Worlds Observatory, as proposed by a prominent committee known as the Astro 2020 Decadal Survey. Scientists believe that though the project seems audacious, it could be easier to complete than JWST, which notoriously exceeded budgets and deadlines, given that rocket technology keeps improving and becoming more affordable. Fortunately, the new telescope will start on a far more solid technological foundation than the JWST did. It will build directly on the JWST's pioneering segmented mirror, as well as the powerful chronograph that will fly on the Roman Space Telescope. Clampin, NASA's astrophysics director, stated during a presentation. The new mission will also have an inbuilt backup plan. The Habitable Worlds Observatory, like JWST, will be located 1 million miles or 1.5 million kilometers from Earth, opposite the Sun, at a location known as Earth-Sun Lagrange Point 2, L2. However, unlike its predecessor, this future observatory will be enhanced by some robotic additions and tremendous upgrades. We'll also design this telescope right from conception to be serviceable, Clampin stated. This decision was inspired based on the success of the aging Hubble Space Telescope, which was salvaged and upgraded with new powerful equipment, severally during 5 astronaut visits, the most recent in 2009. By then, we would make use of commercial companies that specialize in straightforward robotic servicing at L2, he added. How soon will this be? No one knows.